Good evening. Can you all hear me? Yeah, I guess you can. Hi. Good evening. And I just want to start with like a small story. I was driving up here, on the way here, and I saw all the hills on the way on 210, a little too green. And obviously, I'm obsessed with space, I guess. And I was thinking about, oh, so if this is possible in the deserts of California, maybe it's possible in Mars or something like that. Okay, before I go way on board of that, probably the problems like that are what we're trying to solve today with this meetup series. So once again, on that note, welcome all of you. Thank you so much for signing up and showing up. It's a big difference there. On terms of introduction, I am Srinath. I'm from Space Cooperative. I'm here with Yalda, Braden, and Patrick, who's way behind there. So I'm going to hand over the mics to them in a second, but I think I just want to use this moment to thank Innovate Pasadena. I think this meetup won't be happening without them. So thank you so much. I don't know if there's a live stream here, so I don't know if Mark and Alex and Beth are actually listening, but thank you guys. So on that note, you can take it.
Hey guys, I'm Braden, and I'm going to talk a little bit about what this meetup agenda is about. So it's about going to space. Sounds like science fiction, right? So we're here to talk about it and get the creative juices flowing with everyone and see what everyone's ideas are and see where it goes, you know? So as humans, we think that the next expansion is going to be out of this planet into space. Whether you're living on a different planet, a moon, or a space habitat, you know, we're here to talk about that, and it's going to be awesome. And I hope you guys enjoy it. So basically, Srinath is going to start off with a little technical stuff about space flight and space travel, and then we're going to have two speakers, Dan Faber, Randy Wesson, and after that, Patrick, talking about economics in space, politics, kind of the non-technical side of stuff. And then we're going to talk a little bit about Space Co-op, which is where I met Yalda. We actually did a NASA Space Apps Challenge here at Cross Campus for asteroid mining, so kind of out there, but that's where we met, and we started Space Co-op in October, and now here we are speaking in front of a bunch of people. So thanks for coming, and Srinath.
Yeah, thanks, Braden. So, as he said, we're going to go through the presentation in that order. So let me just walk you through this here. Yep. So we already thanked Innovate Pasadena, of course, cross campus. Without them, we won't be here. So thank you, guys. So this is sort of what Braden spoke about. So I'll skip that. So we have structured it in two formats here. There's going to be a technical part and a human considerations part. And when I was thinking about what I'm going to speak, I realized I'm going to be talking about the more usual part, which is the technical part. It's gotten to a point where technical is boring about space now. So that's what this part of the presentation is. Okay, so I mean, if you talk about the technical stuff, there are like a million things going on. We have more experienced people here to talk about that. I just want to give you a very brief overview of how we are thinking about it and some topics. Obviously, this is a meetup series, so things are going to, we're going to evolve over time. So you'll see how that goes. The first thing is, okay, living in space, how do we get there first? That's the first question. This seems to be the most common media item because of SpaceX. Thank you, SpaceX, for that. So yes, we need to figure out a cheap way to get there. Assuming Musk can pull it off, and looks like he will. Let's talk about the other stuff here, which is not totally science fiction, probably the last 2 hours, but the ion, nuclear thermal, all these things are helpful. Definitely not for the first part. You need to get to space. And after that, if we are going from point A to point B, we might use stuff like ion thrusters. Yeah, it's my personal favorite, this image here, this blue thing. It really reminds me of fiction movies. That is actually how the xenon ion thrusters output would look like. Hope I'm right. So that's it. And solar sales probably look like that. It's going to be slow. You can maybe ship cargo from moon to Mars on something like that, but that's what solar sales is. Elevators, we're not even close to getting a material which actually holds up that far. So, but anyway, that's something there. Okay, so we've gotten there. So how do we think about living there, right? So we can talk about this in two aspects. One thing is mechanical life support and biological life support. It sort of covers the same set of issues in a way, but the most important thing is to let me just go to the biological part here. The Yeah, the air has to be clean. We need water, we need oxygen, we need food, we need waste recycling. uh, Topics that are already being done very well on the space station today, but I think maybe Randy will touch about a little bit of this or some part of this, I don't know. And of course Dan, you can do that too. um, then comes the okay, so we are there and we are living. So what do we think about next? Of course, we need to we do that in a sustainable way with power. Um, Things have been figured out. Yeah, you have these solar voltaic cells, solar thermal cells, which is basically just getting heated up and moving in a direction. We have the radioisotope thermal generator, which is not actually a nuclear reaction, but it still gets some heat to get your spacecraft going. So these are the different things that you can talk about in terms of power. And then finally, yes, it's time for me to hand over the mic to a more experienced person. But before that, we do want to talk about how to build stuff. And you can talk about it in terms of how are you building stuff to go actually there, or how are you going to build actual habitats in space, wherever that is, be it in orbit or be it uh, on a planet or a moon. So a lot of opportunities for architecture, a lot of opportunities for it's almost like building a new city in a way. So you can think about the engineering challenges for doing that. So we have all that stuff, and it also obviously impacts the risk analysis that you would do. So how would stuff work when there is no gravity? How would what are you going to do for the radiation? And in both these, we have regulations as a key part because no one has sort of thought about that, and maybe through forums like this we will enable such conversations. So that's one of our goals here. So that's sort of a brief overview. I'm going to hand it over to Dr. Randy Wesson here. I have a bio of you actually printed because I don't want to miss out on anything. Do you want me to read that or you want to introduce? Okay, I'll just read it out. It's a pretty it makes sense to actually read it out. There's a lot of stuff here. So Dr. Randy Wesson is an astronautic systems engineer specifically involved in planetary exploration. He's an experimental economist and writer as well. He has been an employee of the California Institute of Technology's JPL since 1984. Actually, I was born 1 year after that. So uh, he is currently the A team lead study architect for JPL's Innovation Foundry. And yep, so yep, best done through by him. On the side, Dr. Wesson works with Dr. David Porter of Chapman University in the field of experimental economics, where they're designing a system to help allocate resources for building instruments on robotic deep space planetary spacecraft. This proposed system will build on the success of the Cassini Resource Exchange and be applied to NASA's outer planet flagship missions. So that is cool. I was very much fascinated by the experimental economics part because, as I told you, we are not focusing only on the technical part of stuff here. So anyway, I know this is going to be a technical presentation. On that note, I'll hand it over to Dr. Wesson.
Thank you. Let's first set this up.
Yep. So let's put this up.
1 minute. This is what a commercial and dance is great. Let's see if it finds it.
Okay. The task I have today is to explain how one small area of JPL does innovation, and then give you an idea of what we're doing. So I'm going to talk about today a thing called JPL's Innovation Foundry, where we actually work on missions for basically tomorrow. And the talk is going to be first just briefly explaining what it is, and then how we parse this really front end where the idea generation, the hot end of creativity for a project comes in. And then I'm going to give you an idea of some of the stuff we're working on. Now, a disclaimer, the stuff I'm going to show you is stuff that's either an animation or actual hardware. So this stuff is way too mature with the stuff that we're actually dealing with in the foundry, but it gives you an idea of the kind of front end stuff we're working on. So where it started, back in the mid-1990s, the NASA administrator was a guy named Dan Golden, and he really didn't like the idea that missions to the planets were launched once a decade. So his great idea is, he said he wanted to darken the sky with spacecraft. And what he decided he was going to start, the way NASA typically would give missions, they'd say, okay, I'm going to give you $2 billion. I want you to go do a Jupiter-Saturn mission. And then 10 years later, they'd give the next guy, I want you to do a Jupiter orbiter. And it was like a decade per mission. These were called assigned because NASA would just say, here's money, go build this for me. It was assigned. So Dan came up with this idea of competed missions, where rather than assigning a project to a particular center, they'd go, hey, I've got $500 million. Who wants to go where? And the NASA centers would all write proposals, and a team would be a NASA center, an industry partner, and a scientist, a principal investigator, who come up with a concept. NASA would look through these 25 some odd proposals and say, no, maybe, oh, let's do this one. And they would have these competitions. So now we do this all the time. The problem was that NASA gave us very little guidance of really how to do stuff before a project gets formally started. We call it phase A, is the start of a project. Phase A and B are the requirements, the design. C and D is bending metal and actually putting it together. E is launching in operations. So there's very little advice. So JPL, to try to get responsive to this, in 2005, set up something called the Strategic and Planning Project Office to deal with pre-phase A, all the really early stuff. We now go by a much more trendier nomenclature called the Innovation Foundry, or just the Foundry. And it's broken up into shops. There's the A team, which I hate the name of, but it's a short for the architecture team, Team X, and then the proposal shop. And we kind of did this piecemeal because the way Team X really came around first in the mid-1990s, and Team X was responding to a different problem. NASA would say, hey, JPL, I want a Venus lander mission. What would it look like and how much would it cost? And we'd go, wow, I don't know, but give me $1 million in 6 months, I'll let you know. Well, they got tired of it. So they set this thing where we do collaborative concurrent engineering, where you put power, structure, thermal science, programmatics, cost, risk, all together in one room with connected spreadsheets, and we can generate a mission concept in 3 days, all the way down to the parts list and get beginning of life and end of life power. So this happened first, but we found after doing this for about 15 years that there's sometimes you just aren't ready for Team X. What do you do before that? If I said I want to do a lava tube rover mission, you just can't go to Team X because they go, well, what does it look like? What does it do? How far is it going to go? All the initial basics are not established yet. The architecture team is really supposed to be that front end. And we've only been around for 5 years, but we're the front end that feeds Team X. And once you have a point design, then you go to the proposal shop and you write it up. See if NASA wants to buy it. Now, one of the first problems we have, and you need this in every field, is we had no definition, no terminology, no way of speaking about ideas. If I said I want to do a mission, I want to lander on Mars, how do I know the difference between, if two people come up with a Mars lander concept, how do I know the difference between something that has 3 years of work behind it or something that was a good idea in the shower this morning? We needed a way of describing it. So there's a thing that we use in NASA called TRLs, Technology Readiness Levels. It's how you mature a widget to flight. This is CMLs, Concept Maturity Levels. And just to give you a feel for this thing, I'm not going to go through all of it. CML1 is the idea generation. Now, for any scientists out there, you don't start at CML1. You don't say I'm going to do a Martian sun synchronous orbiter at 2 a.m., 2 p.m. orbit. It's, Wow, what's the science question? Was there ever water on Mars? What do I need to look at to prove or disprove that was there? Where does that box have to be? Oh, that's the sun synchronous Martian orbit. But this is where we do the idea generation. Once you have an idea, we do feasibility studies based on analogy to make sure it doesn't violate a law of nature. Can you actually have a delta V to launch this thing? Can you actually produce enough power on target to run the thing? CML3 is trade space exploration. If you look at the Mars Exploration Rover, why go 1 kilometer and stop at 6 sites? Why not drive 2 kilometers and go to 3 sites? Why not go 500 meters and stop at 12 sites? There's a trade space that you want to do. So we actually do that up front. Then we give it to Team X to come up with a point design. Then you write the proposal, and then you're off to the races. And this will work not only in the space field, it'll work in any field. And as you can see, it's iterative. So if you do trade space and all of a sudden you find a landmine, you may go back to another idea, see if it's real, and then go forward again. And the same thing happens again when you get to a point design. You may get something that just doesn't work. But you want to discover the problem here rather than in the other end. The other end gets more time and really expensive to do. Another way to look at the same thing is you've got your idea. You then do feasibility, and once it works, you do this expansion. Not everything has to be traded, but you look at those areas that do, and then maybe you dork it down. It may not necessarily come down to one design. The Europa mission, where they want to study the moon around Jupiter, they came up with 3. Something that orbits Jupiter and passes Europa, which is what 1. Something that orbits Europa, or maybe it's a lander on Europa. But the A team is that part to CML3. This is Team X, which does the point design. So even though it's a smaller box, it takes more work and a lot more detail to do that. And then finally, the proposal side. Now the part you're really looking for. Let me show you some fun ideas that we've been working on. This has been around a while, but this was fun. During the Constellation program, the Altair lander was supposed to land on the moon. You got the astronauts. The habitat module was placed on the top of this thing. Well, the boys and girls at Johnson Space Center really didn't work on how do you get the habitat module off of the Altair lander. Now, normally you'd think a crane. We said, we got this. So we built one of these. This is half scale. This is called Athlete, all-terrain, hex-limbed extraterrestrial explorer. It's got 6 legs, hip joint, knee joint, ankle, and wheels. This thing can either walk or drive. This takes about 2 hours to do what you're seeing here because right now it's like a baby. You have to tell each limb how to do everything. So one idea was you'd actually drive Athlete up to the Altair lander, split in 2 vehicles that we'd call triathlete, grab the pallet, slide off, and then squat down, and now you're ready to drive. The nice thing about this is if you land on the moon and you just put things right where you land, that's colonization. You put it on wheels and you drive and or walk. That's exploration, and you can do international missions because now what you can do is you can put resources on different places and just drive to those locations, and there's no international trafficking of arms regulations you have to deal with because it's just supplies. So that's Athlete. That's actually been built. Right now it's looking for a job. Another idea is, this is a cartoon of Jupiter. The moon that we're looking at here is called Europa. The reason why we like Europa is it's exceedingly flat, very little relief, but it's got these linear fractures. And what we think is, with the Galileo mission, we were able to measure a small distortion in the magnetic field, which told us that it had a subterranean liquid water ocean. So we think it's got a very smooth ice field. We think it may be venting. We have no idea how thick this is. This could be, you know, meters to tens of kilometers. We think there's twice the volume of liquid water here than all the liquid water on the surface of the Earth. Now, we think it may have hydrothermal vents, which is what's keeping it wet. If we were going to explore Europa, we think the wildest place to go is not by the vents, not swimming in the ocean. It's right underneath the ice, because you'd have convection cells bringing material up to the bottom of the ice, and Jupiter's radiation field would be radiating particles that would be falling into the rills. So we started working on a kind of unique mobility system. This is called Baby Brewy. We went up to Alaska to try this. We cut a plug out of a lake. We were with National Geographic, so we dumped a camera in there looking up at that hole. This is Baby Brewy. We dump it into the lake. The puppy is buoyant. So when it drives on the bottom of the ice. Now, you still have to figure out how to get it a 500 million miles out there. You still got to survive the radiation. You still got to figure out how to go through kilometers of ice. You still got to figure out how to get power and commands to it. You still got to figure out how to get data out of it. But we're starting to work on it. We think it's really kind of cool. Well, I'm not done yet. Okay. Let's see. And then let's just keep going. But it's really kind of fun. You just load it with instruments and you let it drive. We like mobility systems. Then the real area that's really just booming these days are exoplanets. These are planets around other star systems. The easiest things to find are the really large ones we call hot Jupiters. So think of things that are the size of Jupiter or multiple size of Jupiter that are so close to their star system, it'd be well into the orbit of Mercury if it was in our star system. These things have days that are hours to a few days long. They're just whipping around. But those are the things you find because those give you the biggest signature when you're looking for them. So we find tons of those. We find these, which are fun. These are orphan worlds. Picture Jupiters that actually get thrown out of their solar system, so they're no longer bound to a star, and they're just floating through interstellar space. And they're just drifting. So they're orphan worlds. They can be warm because they can be generating their own heat. They're just not tied to a star system. We've also found worlds that look like this, that based on density and size arguments, we really believe they have liquid water surfaces. They're just ocean worlds. Now, the problem that you run into is that the light level between the star and the reflected light is 10 billion to 1. So one idea is called a chronograph, where I have it's called an occultation disk, think of it as a thumb, that I put in front of the light so I can see things next to it. There are a couple problems with that. The problem that we're trying to do is we're trying to get a suppression of 10 billion to 1. This is like having a firefly an inch away from a lighthouse, and it's like a mile away, and you're trying to see the light from the firefly. And if that's not dumb enough, because there's dust in these systems, we call it zodiacal dust in our system, you have to deal with scattering there. So it's like trying to do that thing with the firefly on a foggy day. It's like foggy night. Okay, that's the problem we're doing. We also find that when you have this occultation disk inside the telescope, you still get diffraction around that disk, so you're still contaminating the detector. So we thought of a cool way to do this, to really try to get this 10 to the 10th suppression. This is called Starshade. This is the telescope. We have one deploy and then a second deploy. This is about 30 meters across. The edges you could cut your finger on because it's kind of micron size tolerances. You send it, depending on the diameter, 10, 20, 30,000 kilometers downrange, and then you slip it in front of that star system so you can visibly see planets from other star systems. We actually had to hire an origami guy to come up there to help us figure out how to fold this thing to deploy it. And for the, not James Webb, but WFIRST, the next telescope in the, I'm not even going to put a year on it, early mid-2020s, saying that WFIRST has to be Starshade compatible. So they're not putting money into it yet. They're putting money just into the technology to see if we can get this thing ready for WFIRST. The bottom line is the Innovation Foundry has been around for 12 years, and it's composed of a number of individuals that really focus on formulation, because we recognize formulation is not for everybody. We don't do requirements flow down. We're not doing verification validation. It's just really this kind of fast and furious, shallow but broad approach of what kind of ideas we can do to solve these things. For the architecture team, in the past 5 years, we've done over 200 studies. Team X, over 1,500 studies over 20 years, and the proposal shop is just grinding out proposals. So we typically do half of these things when NASA has a particular call. If you want to find out more about the JPL Innovation Foundry, jplfoundry.jpl.nasa.gov. It's got papers on it, and it's got, I don't think it's got some movies, but this is an externally available site that you can look at and download information about it. Thank you. I assume we'll do questions now or later? Questions now or later? Now? Okay. Anybody have any questions? Yes.
Flowcharts with the sort of CML. Can you lay out? Are those available somewhere? Oh.
Okay. Let's see
Are the graphs with the CML description and all that stuff available anywhere?
Yes, if you go to that website, you'll see those papers where they're released, where not only do you see the CML definitions and how you use them. One of the things that we made is what we call the CML matrix. It's CMLs 1 through 5, and it's the 25 elements in a project. So it's instrument development, it's the science, it's the flight system, it's the ground system, it's the technical risk, it's the programmatics, all that stuff, so that you can either see what I need at a given CML or how things mature as a function of time. So the easy one to understand is science. At CML1 on the science row, I need one sentence of what I'm doing for CML1. By the time I get to CML4, I better have a science traceability matrix that talks about the goal, the objective, the observable, the measurements, all the parameters you need. So it's just a lookup table, and that's also in these papers in that section.
Hi, Randy. You've spent a good part of your career, chasing new ideas at a large government institution with lots of, bureaucracy. What are the largest challenges you've come across in that dynamic, and how do you get past them?
The largest challenge we have is we have many more ideas than we have funding for. There is a rational approach how one leaves the Earth, okay? So if you think of robotic exploration, 4 phases. Phase 1 is your swing by just to do the basics. How big is it? How many moons? Does it have a magnetosphere? Phase 2, your orbiter for temporal studies. Phase 3 are your landers and sample returns. Phase 4 is human exploration. I do not believe you do human exploration just because it's fun or to put a flag in there. I think you need to have an economic reasons for doing so. The problem that we run into is that though NASA has, this year it's $19 billion budget, JPL is about $1.3, $1.5 billion. How do you pick and choose what you're doing? And if you have different administrations having different objectives, there's a lot of loss of momentum, and we work under the auspices of what the President of the United States wants us to do, and that's what we do. I mean, there's a roadmap that we have. Science committees, they do these things called decadal reports for Earth, solar system, astrophysics, and that's our shopping list of what we do next. But it's really, God, do I want to say this number? Just to put this in perspective, yes, $1.5 billion is a lot of money. $19 billion for all of NASA is a lot of money. If you look at what the United States spent during the Afghan-Iraq war, we spent NASA's entire budget every 5 days, and we were there for 11 years. So it's really a function of really what you want to do as a country. So what you do is you just try to keep moving along, being as innovative as you can. We still work for the government. We're, in essence, a government agency, so we still have to abide by the things that they want us to do. All right.
What do you see changing in the industry in the next 5 years, and what excites you most?
What do I see changing in the industry in the next 5 years? One of the nice things that we're allowed to do at JPL is we're allowed to push the technology forward. And the nice thing about it is, if you really wanted to do the most science, you'd build one bloody spacecraft and just put different instruments on it and do the same thing over and over again. However, the lab, we're allowed to push a lot of the technology. That's why these spacecraft don't look too similar from mission to mission, even though sometimes they're doing that to cut corners, like Mars 2020 and the Curiosity rover. I think the big thing that's going to change is that probably within 5 to 10 years, we're going to get indirect information about life on other worlds. May not be in our solar system, but we'll see biomarkers. I can't tell you whether it's a microbe or a cow. I can say on that star system, that rock, there's life. And what'll be nice about that, there's a thing that we laughingly refer to as the mediocrity principle, where humans always put themselves on the top of the food chain, and an ugly fact keeps lowering it. So it's like, we're the center of the universe, everything goes around us. Oh, wait a minute, we go around the sun. Well, our sun is special. No, it's just a G2 star. Well, maybe our place in the galaxy is special. Nah, we're 30,000 light years out in the suburbs. Well, maybe our galaxy is special. Nah, it's just a spiral galaxy. When I was going to school, planets were rare, and now we know that there are probably more planets, almost definitely more planets than there are stars in our galaxy, and depending how you count, there's 200 to 400 billion stars in our galaxy, not to mention trillions of galaxies. So probably in 10 years, you're going to find life on another world. It's probably going to be soup, some sort of microbial thing. And then everybody's going to go, of course there's life out there. How could you think this is the best? But multicellularity is what's really rare. And then you'll find multicellularity, and then you go, well, sentient beings, that's the really rare thing. But there's a great quote by Arthur C. Clarke that goes, sometimes I think we're alone in the universe, sometimes I think we're not. Either answer is terrifying. Another, there's one. Okay. I'll be around all night, just sit right. Okay, yeah.
So at the rate that we're discovering new exoplanets, new star systems, whatnot, at the rate you see technology being since these things, when would you predict we'll be able to penetrate or see past the cosmic microwave background?
When do you think we'll be able to do what?
See past the cosmic microwave background.
Right now, I don't see a technology that's going to do that. Right now, I'm just jazzed with James Webb, because Hubble can go back about 12.2 billion years. In the infrared, we can see something, I think it's like 256,000 years after the Big Bang. There's a billion-year gap here we call the Dark Ages, and that's what James Webb is going to study. We're not going to go further back than that because it's just not opaque and there's no information there that we know of. But that dark region that James Webb's going to study, you're going to see images of the first stars lighting up and the first galaxies coming together. And I can live with that. I don't know how you go back further than the cosmic microwave background. Okay, I'm going to let my next Dan go, but I'll be here all night. Thank you.
Thank you. As the next speaker is setting up his PC, let me read out what I have about him. Doing this only because I don't want to miss out on any important points. So Daniel Faber, he's a lead tech. He is the lead technologist and chief executive of a stealth aerospace startup in Silicon Valley now. He has leveraged his experience as an entrepreneur and engineer to draw together key emerging players in the field of in-space materials technology and successfully connected them to leading venture capitalists. So we need businessmen like him. As the former CEO of Deep Space Industries, an asteroid mining company, Mr. Faber built a solid technology business, aggressively advancing a vision of delivering off-Earth resources to the space economy. Under his leadership, the company released its first products with significant customer traction, grew sales from zero to nearly $10 million, changed global perceptions and regulations around space resources, and positioned DSI to systematically create all the technology necessary for actually mining asteroids. This is not science fiction. As a serial entrepreneur in the aerospace and mining industries prior to DSI, which is Deep Space Industries, Faber has grown several high-tech companies from startup through to commercial success. He's a recipient of multiple innovation awards, and he's been granted a number of patents in the field of mining, medical imaging, and aerospace. So thank you for coming here.
Thank you. Okay, is this working? Great. So I'm going to talk to the topic of living in space and tell you a little bit of the story of where I've seen us get to over the last 20 years and where and why I think that this is an incredibly exciting time, and we're going to see people living in space relatively soon, a lot sooner than a lot of people have thought. I started down this journey when I got to university. I got bored hang gliding and windsurfing and building solar cars and all the other things that you normally do at university, and decided that I wanted to spend my life doing something that was worthwhile. I wanted to do something that was good for the world, something that would keep me interested long term, and started thinking about what those options were. Unfortunately, I learned calculus. And realized that existential risks were the only things that seemed worth addressing, because when you integrate to infinity, you get a large number. And realized that the getting off this rock would actually address a number of those, not all of them, but a number of the existential risks. So I decided that's what I should do. I should try and get people off this rock. Perhaps it's even feasible in my lifetime. So how do we do that? Being in Australia, I grew up in Tasmania. We don't have a national space program. I couldn't join NASA and let the system take care of it. I couldn't join the big aerospace companies. That opportunity wasn't there. So I sat down and said, well, how can I make a difference? How can I get people off this rock? And why haven't these organizations got there already? What's stopping us? So had to confront harsh reality, because sometimes dreams don't come true. I also went past 6'3" and kept going, and there was no way that I was going to become an astronaut for several reasons. But if you want to get people in space, I quickly realized you got to give them a job. NASA's doing great, sending, 3, 6 astronauts on little 6-month holidays. The Russians do the same. The Chinese are now doing that. That's great. But if you want permanent people, permanent settlement, if you want to be living in space, you got to give people a job. That's something they can follow. All the passion in the world, all the good meaning in the world, all the government programs are not going to create permanent jobs in space. The thing that's going to create permanent jobs in space is the right incentives. Specifically that one. How are we going to make enough money to pay for the first permanent job and to keep the guy there permanently, not bring him home? Bringing him home is expensive. I don't want him to come back. I want him to be living in space. One job, the first one. How do we get from 0 to 1? Well, there's a whole bunch that we don't know about living in space. One of the exciting things when you get from 0 to 1 is you start learning. I'd like to give the analogy of why getting from 0 to 1 matters so much. This is vacuum. Everyone who's worked in the space industry has played with vacuum. Everyone who hasn't has probably played with vacuum as well. Your televisions have vacuum tubes. Sorry, they used to. When I was born, all televisions had vacuum tubes. But it's a pretty handy thing to be able to run industrial processes, evaporate things quickly, refrigeration, all those kind of things. When industrial vacuum was invented, the common availability of vacuum, you're sucking the air out of something. It's kind of useless. Yay, now you have a bottle with no air in it. I can't think of anything to do with that. Over the next 100 years, everything changed. All industry changed. Now we get the opportunity to remove gravity. We get to take away the force that dominates the macroscopic organization of matter. And we have no idea what we will be able to do with it. Here's I won't say a bubble. Well, there is. There's a bubble inside a fluid blob that's doing its thing. I challenge anyone to understand how to use that for anything yet, because no one's been up there. Okay, if we gave somebody a permanent job and said, that's it, you're there. You get 12 hours off a day. You can do with it what you like. I'll give you 50% of the proceeds of anything you invent. I can guarantee that within a week we'd have a better toilet, because he's going to have to live with that toilet, and right now they suck. So why aren't we fixing toilets? Why aren't the astronauts up there on this free time trying to fix the toilets? We've got the wrong incentive system. They know they'll be home in 6 months. Their time is scheduled down to the nth degree. I want a permanent job in space. I want that guy working for me and coming up with things that are going to make his life better so he never has to come home. Then I can save money. So I got into this saying, all right, how do we do that? And I looked around at all the business plans, and this is what I saw. Give me $1 billion, and I will save the world. None of them got funded. The great thing that we're seeing today is that there's, well, I don't know if there's less of those business plans, but there's now a lot more business plans that say, give me a bit of money, and I'll make it bigger. And then give me more money, and I'll make that bigger. And then when I can justify $1 billion, and I've got an operating team and an operating company, then I might ask for $1 billion. And the biggest infrastructure project that I'm aware of, not including ISS, the biggest commercial infrastructure project that I'm aware of is the Gorgon gas project in Australia. It's a $70 billion gas project. They're making the world's biggest ship. It doesn't even have engines. They're just sort of parking it there as a floating ocean to refine oil and gas. You can get $70 billion of capital together if there's no market risk and there's no technology risk and there's no geology risk, and you got all the risks beaten out of it, and you can show that it's going to get a good return. And getting $70 billion is easy. All right? What we want to do is easy. We just got to take all of the risks out of it. So how are we going to do that? How do we get from 0 to 1? Well, I wrote a list of all of the industries that I could think of that could possibly generate enough money and would need somebody living in space to get that business going or to keep that business going. And of all the things that could make money in space, I got 3. Space-based solar power, tourism, and mining. Unfortunately, I'd learned calculus and math and realized pretty quickly that you needed the resources from the asteroids or wherever to make the space-based solar power happen. So that left me with 2. I also couldn't see myself as a tour operator at the time. I just started engineering. So we headed down the route of asteroid mining. That was 20 years ago. Learn how to build spacecraft, learn how not to build spacecraft, then learn how to build spacecraft, set up a company doing instrumentation in the mining industry, did a few other crazy things, eventually admitted to the world what I was doing when I joined Deep Space Industries full-time, and we managed to change the world. The world is now different than it was 3 years ago. There are now, and I've got 3 companies here, there are now 6 companies that I'm aware of in the asteroid mining space. I'm not sure that the other 3 are public. There's been a complete shift in the international regulatory environment. This guy really needs a round of applause. If you ever see him, congratulate him. He's the minister of everything in Luxembourg, the deputy prime minister. He's the guy who's really pushing things. Luxembourg, the US put in place regulations in response to industry going and asking for some surety that American companies could own the resources they extract. And that was the usual interesting Capitol Hill work to make that happen. And that law exists. Luxembourg said, hell yeah, I think there's a future in this. We've done this before. We've got the largest geostationary communication satellite company in the world based in Luxembourg, employing hundreds of people, part owned by the government because of the investment they made in it. We can see a similar thing with space resources. If we set up the regulations right, we'll attract the companies to Luxembourg. This is Luxembourg. It's bigger in space than it is on the ground. They have more satellites than anyone else. SES owns 56 satellites. My number's probably changed since I had that. Out of the 400 operational satellites in geostationary orbit, this country knows how to do space. They put aside 200 million euro. What's that? Somewhere between 230, 250 million dollars to invest in space resources. Not just setting up the regulations, but making the investment. That changed everything. It changed everything. So these companies doing well. The deep space industries, of course, I know quite a lot more about that than the other companies. We built a business model that said, okay, asteroid mining might actually not be feasible today. There's a lot of risk. Remember, if you can get the risk out of something and show there's a return, you'll get any number of money you want. But there's a lot of risk. Geology, market, technology, financing, regulatory. How do we beat down those risks? How do we make a product, make a company, prove that we can get there? So DSI did several million of sales last year, has products on the market, has a great team, has shown that it can operate. Planetary Resource doing a similar thing, hyperspectral imaging of the Earth. Transastra working on the business plan, they're a lot newer. So these companies have figured out how can you make a business that directly chips away at that big vision? And that's where we're going. So the world has changed. I think it's now inevitable with 6 companies working on this. It's inevitable that we're going to have asteroid resource supply within 10 years. There's a whole bunch of other things that are interesting that are going to happen as well. But there's one problem. Robots. It's all going to happen with robots. Robots are cheaper than humans. And the early mining, until we have something that's so sophisticated that designing a maintenance robot is more expensive than sending up a human and less reliable that you'll get your right maintenance result. And at the mine or at the processing facility or whatever it is, we're going to use robots. We're going to automate the hell out of this. So, unfortunately, that probably rules out mining as creating that first job. But on the exciting side, the world has changed. In 20 years since I made my first list, I wrote off in-space manufacturing because there were no products. Nobody had anything. Now there are 2 products. Silicon carbide wafer annealing and ZBLAN fiber optic cable pulling, I guess. You do those in microgravity and you end up with a much higher quality product. A product that's so valuable that you can launch the raw material from the ground, do the processing in orbit, bring it back to the ground and sell it for a profit. So we finally have the thin end of the wedge on on-orbit manufacturing. That's exciting. We don't know the size of the market. These companies aren't selling product yet. They're not quite on orbit, but it's coming. All those tests are going to be done. There's I think, flight tests coming up in a couple of months for some of this stuff. So that's pretty exciting. The other one, which hasn't been explored a lot, is media content generation and entertainment. It's a completely new wallet to open up, something that people in the space industry almost don't want to think about. We're engineers. Where's the spacecraft I'm building? What do you mean, football? I don't watch sports ball. One team sports against another sport. Where's the aerospace in that? I'll tell you what, there's money in it. There's an enormous amount of money in it. And I like that because that means I can afford to put the first person up in space if I can find the right business model. So at the moment, Space VR are trying to put up 3D cameras and create content. NASA has NASA TV, but they're not monetizing that. There's a lot of other opportunities. So now we've got 3, whereas before we had, well, 2, I guess. But it's changed. So my interest has now shifted to these kind of areas. Rex has been bugging me about what I'm doing next. This gives you some idea. But here's the thing. I've got 5 business ideas, and I'm one person. I can only push on one of those with a realistic chance of success at this point. I don't have the resources of Elon to run 5 businesses at a time. What this industry needs is entrepreneurs. It needs people to realize that making money means you can buy more engineers and multiply your force and really make things happen. We need people to stitch these business models together. We need to, just like the asteroid mining world, there are now 6 companies. We need to try different versions of business models if we're going to see this succeed. And that's how we're going to get people to space. So that was not supposed to happen, but maybe I had ended. I think I ended on that. I did. Look at that. That's it. We're done. Questions? Hang on, we got microphone things going on. We good?
Hello, yes, thank you. So you said that you were making products and profit right now, but you didn't talk, I don't know, you came back around and I wasn't quite sure what you were doing. What are you doing?
Deep Space Industries. So we released our first product in June last year, maybe a little earlier, which is a thruster. We tried to buy a thruster for our small spacecraft, and we had a lot of trouble. There are a lot of companies trying to build small thrusters for small spacecraft. Let's back up a little. So to do the first missions to the asteroid, the resource prospecting missions, we take a small spacecraft, as small as we could get, so 20, 30 kilos when it gets to the asteroid, and we have to, well, after you get off the ground, that's a shipping business, I don't count that. You have to leave Earth orbit, you have to match orbit with the asteroid, you have to do rendezvous and proximity operations in its low but existent gravity field, and you've got an RCS, a pointing control problem. So this is that 5? I think it's 5 different. And then once you're mining, you also have a return to Earth challenge, which is move 1,000 tons of material back to Earth. So there's 5 different propulsion regimes you're trying to cover. You need different propulsion solutions for different ones of those. We found a solution that would meet 3 of those. And we couldn't find a thruster. No one else was building it. So we built a thruster. And we also knew the microsatellite, small satellite market quite well by the team that we built. So we built this thruster that could move satellites around in orbit. And it turns out everybody's looking for that who's building small constellations. They want to phase their satellites. And some people are talking about using drag by moving your solar panels. Turns out that's really slow, really hard, has a lot of operational constraints. If you put a little thruster in it, you can do a lot. So we built a thruster that had that capability. Importantly for Deep Space Industries, it runs on water, which is the first and easy thing we can get out of the asteroid. But then from our customer's perspective, it runs on water. It's inert, it's non-toxic, it's unpressurized, it's inflammable. You can build your spacecraft around a fully tanked up thruster and do the tests on the bench and never have to pay for any safety equipment. It's full of water. It's a container of water. You can put it as a secondary payload on someone's rocket and no one cares. So now everyone wants them. Nice little product. But then, similarly, we've got a whole bunch of different ideas as to exactly where we want to go and what products we should build. Each of them exactly what we need to get to the asteroids. Each of them tailored then in the first instance to what we can sell in the market. Oh, and then we leverage that into selling complete spacecraft.
Yeah, sure. Howdy, thank you for coming. How do you foresee this technology with automation ramping up? And do you think that the pace and the effectiveness of automated manufacturing and processes will outstrip the relevance of money?
If technology will outstrip the relevance of money?
Yes.
Technology drives down the cost of things. As long as we live in a resource-constrained world or universe, then we have to do a trade-off of where to put those resources. and money is our mechanism of weighing up apples against elephants, right? We have to weigh up completely different things, and we try and come up with a common denominator, and we call it money. So money won't go away unless we completely remove all the constraints from the universe, and I can't see that happening. But there are, I see 5 technologies that are going to completely change this industry in the next 5 years. 3D printing, satellite servicing, asteroid materials supply, AI, and fuel depots. Those are going to come in the next 5 to 10 years. So if you're building a business, build it assuming those exist, or build it around making those exist. All right, you do that, you'll be ready. When the world changes, you'll be able to run with it. So that's pretty exciting. Now, what does AI do in all the rest? Yeah, it helps with the automation. There's a whole bunch of things it's going to get applied to. It's not going to remove the need for money.
Hey, Daniel, for the Luxembourg investments in this whole industry, could you describe whatever you can say about the strings attached with that money? Like, do you have to have businesses there? Do you have to create so many jobs? Do you have to accomplish things on a certain timetable? You know, things like that. I haven't seen much about that.
Yeah, their experience with SES, they created SES as actually an American aerospace engineer and businessman who went over there and said, hey, I think you should get into ComSats. And the regulations didn't exist. The German government, the French government were launching satellites and said, you know, we can only transmit to your area and that kind of thing. But they had experience with the ITU beaming pirate radio into the UK. And so they knew how to navigate that. And the Prime Minister said, we'll build the technology first and the regulations will follow. And they nailed it. They knew what they were doing. But that was a pure play. They bought their spacecraft and they bought their launchers from US suppliers at the time. This time around, they've said, okay, so we're putting this money in. We're not sure if asteroid mining is economically viable. No one is. We know it's going to be viable long term, but is that enough? And so there's different parts of the government want to see different kind of things, and you have to negotiate through. So I'll just say it's a complex negotiation process.
You said you wanted to focus on maybe one of 5 different ideas right now. Can you share an idea of what you want to focus on?
No, if you want to pursue one, chat to me later. What I will say is what I will say is that I'm looking at 3 different I'll call them destinations or objectives. You know, with the high-level goal of settling space, I'm looking at lunar facilities, orbital facilities, and fuel depots, which is the only one of those 5 technologies that doesn't have an ecosystem of companies around it yet. So I'm looking at those, but I'm looking at what business models fall out of that and will help us enable that. Just in the way that DSI started with its little thruster. Okay, now, you know, having done that on a business that on a vision that was not economic when we started, and we had to build that. On a similar vein, I'm not afraid of a business that's not economic as long as I can find something that'll get me there. So each of those are in that area.
Okay, so if it's a combination of hardware or software or a little both?
Yes.
Yes, no? Cool.
All right, I've got them all confused sufficiently now. Right.
Actually, Dan, can I ask you a quick question? When you first told someone about you're starting an asteroid mining company, how many of them thought you're crazy?
Everyone?
Okay. Okay, just checking.
Yeah, I mean, it took me 18 years, something like that, 17 years to go from, hey, I want to do this, to actually admitting that I was doing it, because I didn't want to be the guy with the underpants names business model.
Yeah, I asked the question because it is a common problem with a lot of people who are trying to sell a vision which looks like science fiction, and I just wanted to hear your thoughts on that.
Yeah, don't be afraid of that. Don't worry about what anyone else thinks. Just make sure that you haven't got an underpants names business model, that you know that there's a business model underneath. It doesn't need everybody to believe your business model. Okay, you only need enough people to get it financed and to buy your stuff. Everyone else is irrelevant. Stop trying to convince them all.
Got it.
Once you're making money, all of a sudden everyone believes you. It's amazing.
Got it. Thank you. Here you go. Where do I put this? So that was great. Very different speakers and very different thoughts. Thank you, both of you. So I am going to go to the more non-technological part of the presentation now. And interestingly, Dan unintentionally thought about spoke about something that I'm going to talk about just to start off the topic. I'll actually start about inequality in space. So when we were initially in Space Cooperative thinking about, okay, how to do this in the most society-friendly way possible, we were thinking of a future where everyone is equal, because once you're in space and you're talking about living in space, all of the needs of Earth people are already taken care of. But new problems arise, and I just wanted to talk about gravity. That's one thing that we all take for granted here. It's available for free. That's actually the biggest problem of getting out of Earth, right? But I think once we are in space, one way to think about it is probably we are going to have it as a precious commodity. People who have access to some sort of currency in wherever they're living are only going to be able to afford gravity. So that way of thinking sort of led me to believe that new problems are going to arise, new commodities are going to get precious, things you take for granted are not going to be taken for granted, and something else which we think is precious now, maybe we land upon an asteroid which is completely diamond, in which case maybe diamond becomes the least precious thing here, right? So we don't know how things are going to change, but these are interstitial questions which will affect the societal structure on any space habitat. So that is what this part of the presentation is going to be about. I'm going to give it off to Patrick from Space Cooperative here. This is going to be, and this is the time to ask all the questions. So, Patrick.
Thank you, Srinath. Hello, everyone. Is the volume good? Awesome. Okay. So Srinath opened up with a little bit about the human side, and some of our guest speakers touched on that as well. And I want to start with a question. How many of you have seen the movie Dead Poet Society, featuring the late Robin Williams? So I'm paraphrasing here, but you remember when he said in a lecture to one of his students that engineering, medicine, business, they're all noble pursuits. But beauty, romance, love, and the arts, that's what we live for. So after we have the first job, and the second job, and the 100th job, eventually there'll be other jobs besides engineering and the hard facts of living in space. But right now, no one's out there really thinking about how we're going to live out there. I mean, there's sci-fi novelists and there's bloggers, but governments see the next few steps down the road. But there will come a day when, after that first job and second job, they're going to want to unionize. They're going to go on strike. They're going to want independence. And that's what this jam session is for, to think about how this might play out, how we want it to play out, and what everyone's thoughts are, not just engineers and technicians, but people with liberal arts backgrounds, with political and other non-scientific backgrounds who want to talk about their thoughts living in space. And as Srinath said, this is the part when it's actually best to interrupt me. So if you have a question, just raise your hand. We can send a mic out to you, or if you feel like using your vocal cords a bit, you can definitely just raise your hand as well. And at the same time, we're also having a live stream on YouTube right now for people who aren't in the room. So I'll occasionally stop to answer some of the questions for the people who are watching from around the world. So Srinath already touched on one of the big questions, which was health in space. And NASA has done a little bit of research on it, and they're certainly mitigating the consequences of health for the astronauts on ISS. Famously, recently, Stephen Colbert had a machine on the space station named after himself, the Combined Something Resistance Machine. Because right now, living in space, the lack of gravity, like Srinath said, is a huge toll on the human body. So right now, we don't know what it'll be like for hundreds or thousands of people living in space, where gravity might be a privilege instead of a birthright, as we all have it here on Earth. And then there's also psychological symptoms. Mum is the word when it comes to a lot of the long-term questions for living in space. Confined quarters with people you might not know. The submarine crew certainly have experience living in close quarters, but being under the ocean is one thing. Being millions of kilometers from the next planet is a very different question. And once things start transitioning into you live there forever, that's a big question. So how will we handle that psychologically? And then there's the fun question, the politics. People forget this sometimes in the modern era of politics, but eventually there'll come a time when it's not just mission control telling people what to do. There even was a brief strike by astronauts in the 1970s aboard the Skylab 3 or 4 program when they actually refused to do work. And that was with 3 people. Now imagine what happens with 3,000 people in space who might not want to take orders from ground control for a day. So there might be something analogous to modern naval crews with a strict chain of command, or we can have something less militaristic, but still fairly apolitical, like the science research bases that dozens of countries have on the Antarctic now. We could have something a little more brutal. If any of you have read Kim Stanley Robinson's Red Mars trilogy, you see the dark side of colonialism redone in space, with Earth essentially dominating Mars the way that Britain dominated 2/3 of what is now the modern world. You could have something corporate colonial. James Cameron's Avatar movie touched on this, where you essentially have a private military corporation doing the dirty work, but business is business, and whoever has the gun tends to have the power in this case. Like I said, you could have something a little more Republican, Republican not in the political party sense, but in the sense that you have an elected Congress that represents the people, as opposed to something a little more communal. For example, the Mondragon system of cooperatives. It's a business and political system within Spain started by a Catholic priest in the mid-20th century. And it turns a lot of aspects of modern capitalism on its head without all the downsides we've seen in quite a few countries in the Cold War. And then, of course, there's something a little even more directly to the people, direct democracy. Swiss cantons have these when they have certain proposals to be voted on by either the entire country, part of their country. And most of you, at least, are familiar with the California referendum process. If the people want to vote on something and they don't want or trust Congress to get it done for them, they can get, I think it's 500,000 signatures now, and have it be voted on by the entire state. And of course, tied with economics, or with politics, is economics. But I think I've gone through an entire subject. Are there any questions out there? Comments? Yeah, you. I've actually been listening to the audiobook through my phone just when I'm around, and I don't know how different the TV show is, but I love the political drama aspect of it and how they actually account for these social aspects of it. So, personal fan, to answer your question. Oh yeah, sure. One moment, please. Thank you, Srinath. Any other questions or comments out there? That was a really good one. I love that series. Okay. Yeah, you. Do you want the mic? Or?
So you mentioned the idea of kind of British colonization, which is more kind of a municipality kind of taking over the world. I kind of went to a conference a couple weeks ago in San Francisco that talked about data proliferation, and of course we know kind of in the last 2 years, 90% of the world's data has been created, and so they talked about how Google and Facebook own majority of the world's data, and can actually have greater proliferation than world governments do. So what do you see as the world in terms of colonization being a private market or a public market?
Market for information, or more broadly?
both, I guess. Because information, I feel like the person who has the most information has probably the most access or the most opportunity, let's say, to create change.
Yeah, that's definitely a good point. To kind of tie back to the reference to the British Empire, you were saying there was an Irish member of the UK Parliament back in the 1700s commenting on the US Revolution, and he essentially said, when you have a country that's 3 months away because of sailboats, the home government back in London, in I think Westminster existed back then, didn't have information on how to react to these American revolutionaries the way that now the president of the United States can walk downstairs after having breakfast, see a video feed, and that's unprecedented levels of information in an actionable sense. In a larger sense, for public and private markets, I agree with Mr. Faber that as long as there are constrained resources in this universe, we have to have some sort of standard for exchange, and there will be money. As for who controls it, if we could guess the power dynamics of the world in the next 50 years, we probably would all be sitting in the White House right now. So my best guess, there'll be some bumps in the road and definitely some bruises, but I'm seeing a trend towards something more like European social democracies, but with a higher cost than people want to admit right now. That's my 2 cents. Good question.
I was just going to comment on that. One of the longest colonial empires in the world was the Dutch East India Company, which was granted a monopoly in the Dutch East Indies in Indonesia. I think they held the place for about 450 years. And they had their own army and navy. The British East India Company, was also granted a monopoly by the Brits on trade with India, backed up by the Royal Navy. But their navy and most, or even more significantly, their army was larger than the British Navy and Army as a corporation. Now they've screwed up and lost that monopoly, and the government was able to take it off them. And those political structures held. The British East India Company did not then turn around and take over the British government or stand up against it. So, interesting examples from the past. They were granted monopolies by the government. And it was when commerce was invented and stock companies and insurance and all these things got invented around that exploration in that period. I don't see that we're in a similar time at the moment. I don't see governments granting monopolies and backing them up by the Royal Navy in the way that that Britain and the Netherlands and other countries did back then. But perhaps an analogy to look at, and depending on your political bent, fight for or fight against, is to look at the monopolists in the US during the period of industrialization, and I can definitely see that being repeated, and there are a few signs that may be repeated in space. As soon as the next 10 years, that may come into place. So watch it carefully. In the long run, America survived its monopolists. Indonesia and India threw off the colonial powers. If you've got a long view and the goal is addressing existential risks, then does it matter? But that's perhaps a little impersonal. It's worth a debate.
Good comment.
I thought your presentation was very interesting, and I'm proud of you.
Thanks. Guess I'll one back there.
There's a group out of Vienna, Austria, that is starting to look at actually forming a space-based nation, and it's not for people assets, it's primarily for hardware, but trying to circumvent the difficulties. I think trying to democratize access to space, so small university groups or whatnot, and how to get things into space, avoiding all of so much of the regulation that they feel is unnecessary. So it's kind of got me thinking. I've been talking to them a little bit about what are the issues there, and how does the UN define a nation and quote unquote citizens and so forth. So the US with democracy, it was solving a specific problem, and so I think what you're posing is really valuable. If you have a specific issue, which is colonization or assets in space, and how do you govern that, you're going to come up with possibly a whole new type of government.
Definitely a good thing to think about. Thank you for that comment. All right, I'll continue on unless anyone else has some questions or comments. So closely tied with politics is economics, and a few of our speakers or attendees have definitely talked about that already. Things can get pretty hairy in space. I mean, there's subsistence farming that still happens today. It's happened since the dawn of basic human agriculture, and Mark Watney definitely made it famous with his own Martian potato famine in the movie The Martian. There's also import and aid dependency, and this is a weird thing where disaster-stricken areas in the space station have this in common. When the Antares cargo ship blows up, or when a Russian Proton rocket blows up, that's 6 months of food that the ISS better have saved up that they can survive until the next launch, because they're dependent on imports from Earth. They don't have domestic capabilities, and they rely on what amounts to aid if you compare Earth as the aid giver and the ISS as the aid receiver. So if Martian subsistence and farming and in-situ resource utilization like favors asteroid mining doesn't pan out, it's essentially depending on a very long supply chain. And you can look at history for examples of how long supply chains break empires and break the hold on them. So it wouldn't be optimal. Another option is resource extraction, which is the next best example, in the sense that at least it has a payoff. And I think we all heard about payoff. And when I say resource extraction, what I mean is as opposed to processing. So for much of the developing world in the past 300, 400 years, the Europeans came, they took out the resources, and then they processed it somewhere else and made it valuable. That could be beaver furs from modern Canada becoming clothing for the noble elite in Europe. Or now it can be rare earth metals from China turned into your iPhones. The same thing can happen in space, and that is a valuable and valid economic model. More broadly, we can extend that to something if we have human workers instead of robots, because they wouldn't notice the revolution. We can have some sort of urban industrial economic system in space where we have people living and working and supporting this highly dense, as might be necessary in space, form of economics. Or we can focus on something more intellectual, like a space university that's in space. We could have people doing low gravity, microgravity research. We could have people looking at exobiology on Europa or Titan or Enceladus. And there's certainly payoffs from that kind of research, but it's a huge difference from the kind of extractive economics that come from the more common ways of looking at space is the intellectual side. And then, of course, there's production. Pharmaceutical companies, electronics companies are already looking at that. Like was presented earlier, silicon wafers are an option. Something that's been considered by big pharma is insulin crystallization in space. Apparently it happens better, so imagine having no shortage of insulin, and not only that, but it comes to your house via rocket. Wouldn't that be awesome? So we've covered the social and political aspects. What are people's thoughts on how it actually will play out? And this question already came up already, but how do you think it'll play out in the next 30, 40, 50 years? I want to hear from some of you guys.
All right, I've got a kind of a general concern or broad question. It's whether technology, specifically computing technology, will advance sufficiently in the next few decades such that many of the economic possibilities or motivations for a lot of this space colonization or people going into space are essentially surpassed by VR, etc. I know you talked about potentially some of the potential fields in which we might still benefit from people being in space are entertainment and that sort of thing. And even some of those seem like they could be surpassed by VR in the next few decades, given how quickly the state of the art is advancing. So does anyone have any thoughts on that sort of stuff? Essentially AI and whatnot advancing so quickly that we don't even get people into space for any permanent period of time.
So in case anyone missed any part of that, the perspective was that VR and AI will get so good that there won't really be a reason for us soft humans to actually go out into the depths of space. And that brings up a bigger question. Will it be worth it to go into space? Is Earth a good place for us to put our roots down and stay for good? What do you guys think? Would you go to space personally? Would your spouse let you?
Well, I think to answer your question broadly, I think the question is really how long can Earth sustain human resource consumption, right? Because the UN, for example, predicts right now that by 2050, 2% of the people who occupy 2% of the world will consume 75% of the world's resources at the pace we're going at right now. And so if you look at that metric, that incentivizes people that either we have a very limited window of opportunity to leave, or we risk a way bigger problem.
Anybody else like to comment on that?
I'll put in my 2 cents on this. Yeah, I think perhaps there's a window. If we really value humans, then let's get them off this rock before the window closes.
So another question is, how would we deal with the darker sides of living in space? I mean, in any human-sized population, eventually things go wrong. There's crime, there's sickness, there's revolution, there's disagreement. So how would you guys want to resolve conflict in a severely resource-constrained environment? I mean, you can't just move out. Well, you can, but you're in space.
We follow the traditional approach. Badly.
Got another comment up here, I think.
So one option would be, if for example, in that like localized industrial sort of operation where people have been exported to space basically to work on some project, some sort of behavioral modification. So integrating, if we can crack the code on hormonal balance and our physiology, how that affects our behavior, then putting some sort of chips in people basically so they just work. But like they can have the capacity to think independently, although there will be some sort of like regulation on what their body can go to physiologically. So they're not going to like murder each other or, you know, kind of having like a baseline sort of mentality, I guess. It wouldn't swing too far in either direction, maybe. Or if we can get even better than that, people just won't get pissed off at all. But that's kind of unlikely as of now.
Would that be voluntary implants, or do you think it'd be required for the trip in the same way you have to have car insurance?
Depends. Do they have dependents back home? How much money is involved? You know, these are things that people might be willing to sacrifice their livelihood for their family, so, or their own life for their family in that way, if it becomes that it's not voluntary. So I could see that happening.
Huh. And who do you guys think would be in charge of something like this? Would it be the UN? Would it be NASA? Would it be whatever company sent you up? Like, would Blue Origin be in charge of your chip? What do you guys think?
Wait, I didn't really pay attention to the last question. Can you like repeat that? Sorry.
That's fine.
No, I had a comment on the last question, but
go
as
for
a
it,
new one. So
go for it. Yeah.
So to answer your last question about how combat the dark side of moving in space, I really think is really an important question you pose in your presentation, right? Because I think the biggest problem for living in space now, of course, there's technical side, but the biggest problem I think is that there's not an incentive to go there as a favor, right? I'd say, because you don't have get money there, or even though you get money, how do you like spend that? Right, in space, there's no like thing for you to spend on if you get money, right? So it's a question about how you move from 0 to 1 of how you actually take that step up, moving people in space first, and then you scale it up. And I think it plays out when you get to the scale of thing that you can actually have human colonization out in space. I think it will plays out like the same we can like have here. Like we have court and everything for that. But in a small scale, I think there should be, you know, some kind of regulation for that. I don't know how, but you know, maybe his comment about controlling your hormones and everything.
Well, awesome. We are getting a little close to the end, so I think we got 8 minutes. One more? Okay, we can do one more.
So addressing this question you've got about what it's going to look like in outer space really depends on when it starts and what period you're trying to describe. Like, if you ask me to describe the history of the world, like what happened, you know, it'd be best to say, well, when? If you want me to talk about 1900, that's a different answer than 1950, for example. So, you know, we've got this guy over here talking about the very baby steps that are going to, you know, potentially take place over the next 10 years. And he's building those ideas based on the power that exists right now. Where can you get the money and resources to do that? It may be private companies will have more wealth in 30 or 40 years and they'll be able to do fantastic things. Or it may be that, you know, we'll see what you were describing briefly as a sort of a larger trend in a social democracy, and the governments will take more tax money and they'll be responsible for initiating the stuff. The question of whether the United Nations would be in charge really depends on whether or not it becomes empowered. And how is the United Nations going to gain that power? Are the nations of the world just going to hand their independence over to another organization, or is there going to have to be a war or crisis that precipitates the development of an international political system that's more powerful? And I think the real answer to your question is yes. So in 200 years, it's going to look different than it does in 75 years or in 10 years. It's just going to keep on evolving, and it's going to be complicated. And there's going to be brief periods where you have monopolies, and there's going to be brief periods where you've got a variety of different institutions and actors doing different things.
Great. Yeah, very comprehensive response, and I got to agree with you there. All right. Well, that was a great note to close on. So without further ado, I think we'll pass the mic on to Yalda, and she has a few closing remarks. Yalda?
Hello, everyone. Thanks again for coming and sticking it out. Just wanted to give you some background about Space Co-op or Space Cooperative, the organization that Srinath, Patrick, and Braden and I are part of. So let me get closer to the presentation. So what we're doing is we feel like one part of, something that can help solve us, something that can help accelerate us to get to space is if there was a platform where people can congregate and start talking about what their plans are, what their dreams are, what their visions are, because right now basically all we have are Facebook groups, and Facebook groups aren't very action oriented. You can go there, you can post an idea, like, you know, people can make comments, but it's like, how do you actually take action on the ideas? So so what we're proposing is like a platform that will have an ecosystem where there are ideas. Someone can say, yeah, that's a great idea. And someone can say, oh, I can help with that. And, you know, it's just like a iterative process where, let me just start to show you just some designs of it. So for example, you can go to the website and you figure out what planet do you really want to go to? Do you want to go to Mars? Do you want to go to Europa? So you find your planet, you find your mission, and then you start doing the concept development process or the concept exploration process, and you can just regardless of if you have the aerospace engineering background or not, you can just start learning about it, start talking to other people about it, and that's the whole idea here is basically a social network where you can collaborate on space missions together. So there you see Patrick there. He has his social profile and different missions that he's part of, his publications, and then I guess that's about it. But Srinath, do you want to talk more about anything? I'm really bad at presenting.
Thank you, Yalda. I think, this is one boring Sunday evening, and Yalda just pinged me and spoke about Space Cooperative, and that's why I'm here today. So I want to thank her for, giving me this opportunity. But yeah, so as she pointed out, we are more than about just engineering, as you all participated in the jam session that Patrick just did. So yeah, any part of space or living in space that interests you, you might probably find something going on here about space art or whatever. So even if it's something space music stuff or whatever it is, there might be something here. So please check it out. Check us out on that. Yep, I think with that, the presentation itself is over. And we get a lot of questions about, okay, are you just a software startup? I mean, first of all, I don't think it's that easy to have a software startup. And second, no. We are already getting into hardware a little. So Patrick actually dreamt up with an idea for having a bunch of CubeSats in a really small space, and his abstract has been selected to be presented in the CubeSat Developers Conference. We'd like to work with you on that, because that's what this is about, not just the four of us holding up in a corner and doing some work. So please reach out to us if you want to do something about that. The abstract actually is on our blog, which is on the website. So you can check that out and reach out to us. We are more than happy to work with you. So on that note, I guess, as they say, all good things come to an end. But actually not really, because this is a meetup series. So we will be seeing you again, hopefully in a month, maybe last 2 weeks of March. We'll post it up on our website again. So please follow us on Twitter, on Facebook. And yeah, tell your friends that you attended a really cool space event today, if you believe that's what happened. Thank you.